about your mathematics past paper
regarding about trigonometric ratios and identities. Please enjoy.
Hello, my name is Jesslyn from class 11, and today I'll be explaining the answer to Pure Mathematics AS level, question paper 8M0/01, May 2023, specifically question 12, where it's asking us to show and solve and also find the number of solutions to these equations. So let us first start with question A, part A. Now it's asking us if 4 tan x equals to 5 cos x can be rewritten as the one shown here. Now we know that they have sin in this equation, so what we want to do is also put in the sin within this equation, and we know that tan x can also be equal to sin x over cos x, because it's 5 over x. And then we can put down the equals to 5 cos x like this, and seeing this equation, we know that we can multiply the cos x to the other side, giving us 4 sin x equals to 5 cos squared x. Now we know that cos squared x is actually equal to 1 minus sin squared x. This is a part of the trigonometric identities, and we can put this identity over here, hence giving us 4 sin x equals to 5. Don't forget to put in the brackets because we're multiplying it, so 1 minus sin squared x. Now what we want to do is to expand the brackets, so we want to multiply the 5. So 4 sin x equals to 5 minus 5 sin squared x. And as you can see, they already look pretty similar, and all we want to do is just move the right side to the left side, which would give us the negative would turn into a positive, so it will give us 5 sin squared x. And since the 4 stays in the left side, we keep the sign plus 4 sin x, and the positive will turn into a negative, so minus 5 equals to 0. And with that, we have solved the first question of part A. So now that we've solved part A, let's solve part B. Now in part B, it's asking us to solve within the domain between 0 and 360 degrees for the same equation, which is 4 tan x equals to 5 cos x. And they want to give us give the answers in one decimal place. So we know that since these two equations are the same, and this equation can be rewritten as 5 sin squared x plus 4 sin x minus 5, we can use this equation over here. So we can write down 5 sin squared x plus 4 sin x minus 5 equals to 0. And the reason why we want to use this equation instead is because this equation is actually a quadratic equation. And to show it clearly to you, let us put a variable within sin x. So for example, the variable I choose is the letter u. So let u be equal to sin x. And now we can just substitute the value within this equation, which would give us 5u squared plus 4u minus 5. So this should look familiar, and we want to solve for u, and we can do that by using the quadratic equation, which is minus b plus minus square root of b squared minus 4ac divided by 2a. So we want to add these values to this formula, which would give us minus 4 plus minus root of 4 squared minus 4 times 5 times minus 5 divided by 2 times 5. And you can just input this value into the calculator. So minus 4, let's start with plus root of 4 squared minus 4 times 5 times minus 5 divided by 2 times 5. So our first value would be 1.48. Now, seeing these two values, we actually want to use the positive one instead. And that is because minus 1.477 or minus 1.48 won't be valid in the inverse sin. So it is out of the sin range, therefore we cannot use this. We need to say it will be an error. Now, once we've gotten the value of u, we can just place it into the formula, or let u be equal to sin x over here. So it'll be 0.68 be equal to sin x. Therefore, to find x, we can just sin inverse d 0.68. And this would give us an answer of 42.8 degrees. But this isn't, we're not supposed to stop here because there should be two answers to this one. And we should know by using the quadrants. So we know this is A, S, T, C. And since this is a sin, we can assume that the angle is approximately over here. So 42.8 degrees here. And we want to find the other value in which sin is also a positive. And to do that, we can just simply subtract it by 180. Therefore, 180 degrees minus 42.8 degrees would give us a value of 137.2 degrees. And that would be our second solution to the answer. So, yeah. Okay, so now that we've solved part A and B, let's move on to part C. I'll just clear up some space here. So, for part C, it's asking us to find the number of solution from this equation. Let's write down the equation first. So, the question gave us a new equation, which is 4 tan 3x equals to 5 cos 3x. Now, you may notice that this equation is actually very similar to the first one given to us from the question. The only difference is that this has a 3 in the equation. And that's because if you place this into a graph and compare these two equations, the graph will be compressed horizontally by a scale factor of 3. Therefore, if we compare it, so we can write down the first equation, 4 tan x equals to 5 cos x. We know that this is greater by 3 times. And we know that from this equation right over here, there is approximately 2 solutions, which we have thought of. Hence, to get the solutions, or to know the number of solutions from this equation, we can just simply multiply the number of solutions in this equation by 3, because again, the scale factor is 3. So since there's 2 solutions from here, we can multiply it by 3, which would give us 6 solutions. But wait, we can't just end here, because it says in the interval between the domain 0 to 1,800. Meanwhile, the first equation is only within the domain of between 0 and 360 degrees. So, what we want to do is that now we've gotten our new number, 6. Now let's compare the domains between the two equations. So the first one is between 0 and 360 degrees. And the second one is between 0 and 1,800 degrees. We know that between 1,800 and 360, they have a 5 times difference, meaning 1,800 is 5 times greater than 360 degrees. We can just simply put it in the calculator and divide this number, 1,800 by 360, you get 5. So we want to do the exact same thing over here to get the number of solutions. So we'll use our new number 6 and multiply by 5 so we can convert it to the new domain, or the new interval, and we get 30. Therefore, in this question, there'd be a total of 30 solutions. And as for the explanation, it's basically everything that I've just said. You can just say we will multiply the initial number of solution by 3 and by 5 to match the new conditions of the question. Hence, giving us a total of 30 solutions. Alright, and that is all it for the explanation that I have regarding question 12 to this specific past paper. Thank you for listening, and you get to enjoy the others' explanation.
Hi Miss Beth, I'm Kate and now I'll be doing my part for this video. So for my part, I'll be taking from Pure Mathematics AS level, paper 1 with the code 8MA0/01 from the month and year October 2021. So I take it from question 12 and here's all the questions I have. So I have like 3 questions, each of them are children. So let's start with I first. So basically I is asking us to solve the equation 5 cos squared theta equals to 6 sin theta with this domain. 0 is less than, theta is less than or equals to 450. And it will be in one decimal place, all the answers. So if we want to solve I, the first thing we can do is to solve this equation first by itself without the domain. So we can simplify it. So here's how we do it. Let's write this first. 5 cos squared theta equals to 6 sin theta. What we can do first is move it to the left side, the 6 sin theta. So we become 5 cos squared theta minus 6 sin theta. The next thing we can do is convert cos 2 theta to one of its trigonometric identities, which is cos squared theta equals to 1 minus sin theta is squared theta. So this is the identity, which came from this trigonometric identity, sin squared theta plus cos squared theta equals to 1. So let's change this now. And now since we have to notice first that it's 5 times, it's like 5 times cos squared theta. So we can just put 5 in the brackets 1 minus sin theta squared in the brackets minus 6 sin theta equals 0. And now we can just multiply them in. Oh, by the way, if you want to directly just put 5 minus 5 sin squared theta, it's fine. It's up to you how you want to do it. Do whatever is simplest. So, but let's make it simpler this way. So 5, and we just multiply. 5 times 1 is 5 minus sin theta squared theta is times 5 is 5 sin squared theta minus 6 sin theta equals 0. Now, here we can just rearrange the formula and divide it by negative, since this one will be in front and will be negative. But let's write it first. 5 sin squared theta minus 6 sin theta plus 5 equals 0. Then we can just divide it by negative. So 5 sin squared theta plus 6 sin theta minus 5 equals 0. And here you can notice it's like it has the same equation, more like similar quadratic equation as Jesslyn had in her video. So that means we can just, as what she had done, we can convert the sin here into a variable. So let's just use x to make it simpler. So let sin theta equals x. So we can convert it to 5x squared plus 6x minus 5. Now since you notice that this is a quadratic equation, what we can do is either factorize it or use quadratic formula. But if you don't use factorization, it's not possible because there will be no answer. So we can just use quadratic equation instead. So x will be minus b plus minus square root of 12b squared minus 4ac divided by 2a. So let's put them all in. 5 will be a, 6 will be b, and minus 5 will be c. So it'll be minus 6 plus minus 6 squared minus 4 times 5 times negative 5 divided by 2 times 5. And here we can just times them all, simplify. So it'll be minus 6 plus minus 136 divided by 10. So let's put them in the calculator. So if we put them in the calculator, let's start with the positive one first, which will be 0.566 and so on. So let's not try to put in one decimal place first to make the answer more accurate. And next, the negative one, if we change this one to minus, it'll become minus 1.766 and so on. So here's our two answers for x. But we can only use one. And the way we can decide by looking at this, if we try putting the sin, inverse sin with this number, it won't come out as any value. There will be no value at all. So we can't just erase this one. We will use this one. So this is our sin theta. So let's rewrite that into sin theta equals to 0.566 and so on. Now we notice that the sin value is positive, right? So that means whatever answer we find in I will always be in the quadrant where sin is positive. Now then it as ASTC. Now since it's positive, that means it will be found in quadrant 1 and quadrant 2, which will mean we find theta and 180 minus theta, which are both. And also one last one, since it's to 450, it means we will go in full circle again, and which means we'll find another answer here, which will be 360 plus d theta. So let's find theta first, the first answer, which will be sin inverse of 0.566 and so on. Hold on, let us put this in the calculator. Sin inverse of that answer is 34.48. Or, well, since it's in one decimal place, let's put them in 5. So let's find the second one, which is 180 minus theta, which is 180 minus 34.5. So let's put that in the calculator again, which will be 145.5 degrees. Oh, don't forget to put the degree. And let's find the final one, the last one for the first question, or the first part. So it will be 360 plus theta equals to 360 plus 34.5. If we put that in calculator, it will come out as 394.5 degrees. So here's all the answers for part 1. And now that we're done with this, let's erase this so we can continue with part I2A. Okay, now that we're done with part I, let's continue with IIA. So IIA is basically asking us to find the two errors or omissions that the student had made in trying to solve the problem of solve for this domain, minus 90 degrees is less than x is less than 90 degrees, for the equation 3 tan x minus 5 sin x equals to 0. So here is what the student had wrote in their answers. And here's their answer, 3 tan x minus 5 sin x equals 0. This might take a bit more. So this is what they had wrote for their answer. And if you want to try solving this question, what we can do is either we start examining their answer one by one, or we can try doing it on our own and compare to their answer and find what they had done wrong. So I will personally try solving the equation first on myself, the problem. But it's up to you what kind of method, but here's my method. So let's try doing this on our own. So it's asking us for 3 tan x minus 5 sin x equals 0. So the first thing we can do to solve the equation given is by turning tan x into one of its trigonometric identities, which is sin x divided by cos x. So let's do that now. 3 sin x divided by cos x minus 5 sin x equals 0. Now this 5 sin x, we can just put a 1 under there, and then afterwards what we can do is cross multiply it. So cos x with 5 sin x and 3 with and sin x with 1. So it will become 3 sin x minus 5 sin x cos x equals 0. So this is what we get, and afterwards we can just take sin x, because if we look at the equation closer, we notice that both of these have sin x. So we can just take the sin x out. So sin x equals to 3 minus 5 cos x, since we are taking them out by dividing, and equals 0. So here is what we got. So afterwards we can do this. We can just take sin x out. So sin x will equal to 0. And the next one is 3 minus 5 cos x. So 3 minus 5 cos x equals 0. And here we can just convert it. So we can find it. So we can get the cos to find the answer we need for the problem. So let's do this. 3 equals 5 cos x. And then if we want to take cos x on itself, we have to divide 3 by 5. So cos x will equal to 3 over 5. Now this is the one we'll be using to solve the questions. So let's look at the question again. The domain is minus 90 degrees, is less than x, is less than 90 degrees. So if we draw it right here, it'll be, so that means we'll take from here and here. And this is its cos x is in positive, that means the cos will be here both. Or else, if it's more easier, we can just draw the graph. The graph is more easier to illustrate, so it'll be something like this. Which means we will have, and since it's 3 over 5, if we find then 3 over 5, it will be somewhere like here. So let's try finding the data first. The data, one of them will be negative. So let's find the first answer. First answer, which means it will be somewhere over here. It will mean we have to inverse cos with the answer 5. We find 3 over 5. So if we put that in the calculator, inverse of cos 3 over 5 is 53.1. Oops, forgot to turn off my phone. And this is our first answer. As for our second answer, since this is our first answer, it will be here. And since it will be on equal sides, like right here, that means that our other answer will be negative. Just like since we go around here and 1 over here. So this is the answer for the problem given. And now let's compare it with the student's answer. So here we can see that so far in the first 2-3 lines, they basically did the same thing as I had did. But now if you notice in the fourth line, instead of taking out sin x, they had directly divided sin x out of the equation, which is something you should have done, because if you didn't do that, you will have never got sin x equals 0. So that is the first error or omission they had done. The second one is the answer. For the answer for the problem had 2 answers. Oh, sorry, this has to be x, not delta. X. And we have noticed that the answer should be 53.1 and negative 53.1 degrees. But here we can see they only put 53.1 degrees. So So which means they have omitted negative 53.1 as well. Since the graph is asking from minus 90 degrees, less than x is less than 90 degrees. So this is what they have done wrong in the part I2A. Okay, now that we're done with IIA, let's move on with IIB, which is asking us to find the value of A4 from the equation cos 5A plus 40 degrees equals to 3/5. And we have to find all the A1, A2, A3, A4 from the first four possible solutions, which you can find the value of A4. So first, what we can do is just take this, let's just write down some math first. IIB cos 5A plus 40 degrees equals to 3/5. Now, if you look at the value of cos, we know that it is positive, and it's similar to like the previous question, right? And previous part, right? So since it's positive, if cos is positive, that means we can find it in quadrant 1 and quadrant 4. So this is what it looks like in the quadrants. It'll be here and here. And now since it's asking to find, since we have been given the first four possible solutions, A1, A2, A3, A4, or you want to refer it as alpha, but it'll be easier for A. That means we have to find it not in just only this one rotation, but also the second one. So for A1, that means it will be theta. It will be theta here, and in A2, alpha 2, it means it will be 360 minus theta, and then A3 is going up again to a new rotation, to another full circle. So that means it's 360 plus theta, and since we're going for another one, A4, that means it will be 720 minus theta. So let's go find all the values, all the angles for A1, A2, A3, and A4. So let's start with A1. So A1 is just cos, the inverse of cos 3/5, and since this is just the same as before, that means the answer will be 53.1 degrees. So let's move on with A2. A2 is 360 minus the theta, which is 360 minus 53.1. And let's put that in the calculator. 360 minus 53.1 will be 306.9 degrees. And the next one is A3, which is 360 plus theta, so it will be 360 plus 53.1. It will be 360 plus 53.1. If you put in a calculator, it will be 413.1 degree. And A4, which is what we'll be using to find the value of A4. So A4 will be 720 minus 53.1 degree. So put that in the calculator again. It will be 66.9. So this is the angle we will be using to find the value of A4. So if we want to find the value of A4, we have to look again at the equation they've given us. Here cos, the angle here is 5A plus 14. So that means we can put it, so that means the angle equals to 5A plus 14. And since we're finding A4, that means we'll be using 666.9. So we will replace theta with 666.9 equals to 5A plus 14. The next thing we can do is just basically do basic algebra, just move it around. So that means 666.9 minus 40 will equal 5A. And since we only want A alone, we can divide the whole equation on the left side by 5. So 666.9 minus 40 divided by 5 equals to A. So that means the value of A4 will be, just put this one in calculator again, unless you want to do mental math on your own. It will be 125.38. But hold on, the question is asking us to find the nearest degree. So because of that, let's just round it up by the whole number or the degree. So it will be 125 degrees. So this is the value of A4. And now that's all for my part. I hope you enjoyed it. I hope you could understand my explanation and could find it valuable. So let's move on to the next explanation. Bye bye.
Hello there, my name is Samuel. So after those few questions by Velas has explained, so we're moving on into a newer question. This question was taken from the mathematics level, my bad. It was from the year June 2022. So without further ado, let's just start, shall we? So here we have a sample of a question. Given that y is equals to cosecant theta. Might have to adjust my camera angle, see if it's clear. There you go. So here we're asked to express y in terms of sin theta. So this question wants us to express this in forms of sin theta. So as we know that y is equals to cosecant theta, or you might want to call it a c, that's in a shorter form. So cosecant function is equals to 1 over sin theta. So this is the function. Simplest form is that what is cosecant equals to? It equals to y. So y is equals 1 sin theta. As simple as that. Or you might as well want to write it equals to 1 over my negative 1 sin over negative 1 theta. It's the same thing, but I might recommend using this though, because we may not really need this. So moving on to the second question. Hence, prove that dy over d theta is equals to minus cosecant theta cot theta. So here I might have to use like a different kinds of formula, which was called a differentiation formula. And the way we use it is that we find the values of dy over d theta. So with this function, so dy and over d theta, using a differentiation formula, which is going to be d over d theta open brackets sin theta minus 1. So here the sin theta here is the outer function, and because it was the outer function, which means the inside function is sin theta, and the derivative of sin theta is cos theta. If you are wondering where the cos theta actually came from, let me write the equation first. So d over d theta, something. So the functions will be written as such. 1 minus 1 times by sin theta negative square negative, and also cos theta. So cos theta here is like the sin's derivative, and this one is the inside function, which leads to this result, which was to cos theta over sin squared theta. So we are not done here yet, because this is finally the value of dy d theta. However, the question asks us to prove that this one is equals to this. So let's rewrite it. So we have found that dy over d theta is equals to minus cos secant, my bad, cos theta sin squared theta. And here it is. So this is minus cosecant. Let us divide this value. So minus cos secant theta or theta. So cosecant is equals to 1 over sin theta. But this one is negative, so you're basically just rewriting it again. Sin theta, there you go. And also multiplied by cot theta, which was equals to cos theta over sin theta. So you calculated this. What does it result to? Sin multiplied by sin, it was sin squared theta. And the negative is here, that's negative 1 multiplied by cos theta. Exactly, it's negative cos theta. So, we finally able to prove that dy over d theta is equals to negative cosecant theta multiplied by cot theta. And it has expression following such because minus cosecant theta being multiplied by cot theta is the same way as how we differentiate dy over d theta. So therefore it was proven. So the last question will be, show that this expression is for this expression. Since there's not much space, I might like erase all of this, or I might like erase a few of it. So moving to the last question, A3. So as we know that y is equals to cosecant theta, right? Y equals cosecant theta. We move this expression into this. We are replacing this formula with this. We're replacing y with cosecant theta, which will be written as following. So cos secant, or I'm just going to write CSC because that's more easier. CSC squared theta minus 1 over cos theta equals cos theta. We'll save this for later because we want to prove this. So as we know that cos squared theta minus 1 is equals to cos. Yeah, I'm trying to remember back here. So cosecant squared. So cosecant squared theta minus 1 is equals to cos theta, or cot. I remember something. This one is equals to cot squared theta. Yes, cot squared theta. However, since there is a root here, we can erase this equation so it becomes, more clear result. So this one is cot squared over CSC. Cot squared is because like CSC squared something minus by 1. And since that there is a root over here, we erase that and it becomes just cot theta over CSC, or cosecant. It does not have here. So since that we finally found this, we can express it again. So cot is equals to cos theta over sin theta, and CSC is equals to 1 over sin theta, and this will lead to this cos theta sin theta, cos theta over sin theta over 1 over sin theta. And the way of how we use this is that the way how we divide this fraction is this: cos theta sin theta. We switch the place back up again, and this would result in cos theta over sin theta multiplied by sin theta, because this is 1 and then you flip this, switch it over, it's just going to sin theta. So finally, we can cross this and with this, leading to cos theta, and we finally found the answer. And as such, we are able to show that root y squared minus 1 over y is equals to cot theta. So that is the whole answer for this question. And my name is Samuel Richard. I'll be greeting you guys a happy Wednesday. Never mind, happy Friday, whatever it is. Thank you and see you later, perhaps.
So the following is from pure mathematics, AS level, from A and A0/01 from June 2019. It is in question 13, where part A is to show that 1 over cos theta plus tan theta equals to cos theta over 1 minus sin theta, where we are told that theta does not equal to an odd number, as it is written as 2n plus 1. So to begin, we can just rewrite the question, which is 1 over cos theta plus tan theta, where our desired result will become 2 cos theta over 1 minus tan theta. Where here we'll just expand the tan theta, where it's going to become 1 over cos theta plus sin theta over cos theta. Now we can just then add this. We can just add this on the left hand side to become 1 plus sin theta over cos theta. Now let's focus on the right hand side, where the right hand side is going to be cos theta over 1 minus sin theta. Where what we're going to do is to rationalize the denominator, where cos theta over 1 minus sin theta will be multiplied by 1 plus sin theta over 1 plus sin theta. Now rationalizing the denominator is used mainly on trigonometry, identities, to find and simplify certain equations. Where after we do this, we will be left with cos theta multiplied by 1 plus sin theta over 1 minus sin theta multiplied by 1 plus sin theta. Now using the identities of 1 minus sin theta squared equals to cos squared, we can just multiply this, which will give us a 1 minus sin squared theta. So that we're going to be left with cos squared theta. So the new equation will become cos theta over cos theta multiplied by 1 plus sin theta over cos squared theta. Or we're just going to get rid of the cos by dividing by the denominator, which will give us cos theta, which means at the top and the numerator, we're just going to be left with 1 plus sin theta. Now what this means is that this is going to be the right hand side, which is going to be the desired outcome we have to show. Whereas in the first part, we have already shown that this is the left hand side. Therefore, this has been proved and has been shown that 1 cot over cos theta plus tan theta equals to cos theta over 1 minus sin theta. It may not look different, however, its value is exactly the same. For part B, first off, we can use part A to solve part B, whereas in part B, we are told that given that cos 2x does not equal to 0, and the domain is 0 is less than x, which is less than 90 degrees, we are also told that 1 over cos 2x plus tan 2x will equal to 3 cos 2x. Now, observing part A, 1 cos 2x, 1 over cos 2x plus tan 2x is exactly the same as 1 over cos theta plus tan theta, but the theta is replaced by a value of 2x. Therefore, using that logic, we can rewrite the equation as cos theta over 1 minus sin theta equals to 3 cos 2x. But we have to remember that the theta is changed by 2x, by the value of 2x. So therefore, it will be cos 2x over 1 minus sin 2x. Now after this, we can just move it all into one side, where we're going to move the right hand side. So first we're going to move cos 2x. Move 1 over 1 minus sin 2x. So it will be cos 2x equals to 3 cos 2x multiplied by 1 minus sin 2x. Now for this, we're just going to do rainbow multiplication. Multiplying this with 1 and minus sin 2x, which will give us cos 2x equals to 3 cos 2x minus 3 cos sin 2x. Then we can just move cos 2x to the right hand side, which will give us 0 equals to 3 cos 2x minus cos 2x minus 3 cos sin 2x. Then we can just simplify this one by 0 equals to 2 cos 2x minus 3 cos sin 2x. Then we can also just factor out cos 2x from this equation, giving us 0 equals to cos 2x open bracket 2 minus 3 sin 2x. Now this will give us the two possible answers for x, where it's going to either to be used by, we're going to either use cos 2x or 2 minus 3 sin 2x. But we know that for cos 2x, it cannot equal to 0. Therefore, we're going to reject this immediately. So we're not going to use this one, but we're going to use this one instead, which will give us, so we're just going to rewrite this so it's easier to see, where it's going to be written as 3 sin 2x minus 2 equals to 0. So we're just going to move the minus 2 to the right hand side and the 3 to the right hand side, giving us x sin x sin 2x equals to 2 over 3. Which will give us 2x equals to sine inverse 2 over 3. Resulting in, once we calculate the calculator, (41.81), etc. But we are asked to give the answers to one decimal place, meaning it's going to be 41.8 degrees. Now we should have two answers. So here we also got sine 2x is going to be 2 over 3, where the angle is 41.8 degrees over here in the ASTC. Where we know that the domain is 0 is less than x, which is less than 90 degrees. Therefore, we know that this right here will be 41 degrees. That's what. So what this gives us the answer that one of the values here will be in the second quadrant. Therefore, all we have to do is, for the second 2x is equal to 180 degrees minus by 41.8 degrees, which will give us 138.2 degrees. Now these two values are the value of 2x, where what we want to find in solving is x. So therefore, for the first x, it's going to equal to 41.8 degrees divided by 2, which will give us 20.9 degrees. And for the second x, it's going to be 138.2 degrees divided by 2, which will give us 69.1 degrees. Therefore, the values of x are equal to 20.9 degrees or 69.1